that we've reviewed differential equations, we can get to exponential growth and decay. Now, in many applications, the rate of change of a variable y is proportional to the value of y. So remember, rate of change just means derivative, so the rate of change in y is proportional to some value of y, so k times y. If we solve this differential equation, we can separate variables like we did before, multiplying both sides by dt. dy is equal to k times y times dt. I need all my y's on the same side, so divide both sides by y, and you get dy over y is equal to k times dt. Now that we've separated our variables, we integrate both sides. We end up with the natural log of the absolute value of y is equal to k times t plus c. Moving over to the right because we ran out of space. If we're trying to solve for y, remember what we're going to do is we're going to let e be the base and say e raised to the left-hand side, the natural log of the absolute value of y, is going to equal e raised to the right-hand side, and that's kt plus c. These cancel. Since it's an exponential, we no longer need the absolute value bars around our y, and we have y is equal to, and remember we could rewrite this as c e to the kt. Given this differential equation, we come up with this formula. We know that y equals c e to the kt is the solution for the differential equation where a rate of change of a variable is proportional to some value of y. And this formula right here is just the formula for exponential growth and decay. So we don't want to solve that differential equation over and over again. You just need to know that the formula for exponential growth and decay is y equals c e to the kt. And this is going to be where c is the initial value of y. K is called that constant of proportionality or rate. If k is greater than 0, you have exponential growth. And if k is less than 0, you have exponential decay. So the formula for exponential growth or decay is y equals c e to the kt. Again, you're not going to be solving the differential equation to find it. You just need to know that that's the formula we use for exponential growth and decay. So let's look at the examples on the next page. Example 5 says that radioactive radium has a half-life of approximately 1,599 years. How much is left of a given amount after 1,000 years? All I know is that I have a half-life of approximately 1,599 years, and I'm asked how much is left after 1,000 years. So we know we're going to be using the formula for exponential growth and decay. This is decay. This is going to be y equals c e to the kt. Now I'm not given c, I'm not given the initial amount, but I'm also just asked of any given amount. What we know here is that when t is equal to 0, your y would equal 1 because you'd have 1 of whatever it is. And then since your half-life is 1,599 years, when t is equal to 1,599, you'd have half of that left, which is a half. Well, that's enough information to solve for k, your rate for this problem, to then help us figure out how much is left after 1,000 years. We would say here that 1 is equal to c e to the k times 0. So we're saying that c is equal to 1, and then 1/2 is equal to 1 e to the k times 1,599. So 1/2 is equal to e to the 1599k. Solving for k, the natural log of a half is equal to the natural log of e to the 1,599k. Here the natural log and the e cancel, and the natural log of a half is equal to 1,599k. Dividing both sides to solve for k, we end up with the natural log of a half divided by 1,599 is equal to k. So we have the formula y equals 1 e to the k, which is natural log of a half divided by 1,599 t. So how much is left after 1,000 years? Y is going to equal 1 e to the natural log of a half over 1,599 times t, which is 1,000. Plugging that into a calculator and rounding to 2 decimal places, we'd have, well, we don't need the 1, so this is just going to be e raised to the natural log of a half divided by 1,599 times 1,000, and you end up with 0.65. So 0.65 would be how much is left of a given amount after 1,000 years. The next example that we're looking at deals with interest, and there's two different formulas for interest. We have the formula for interest that is compounded continuously, and that's A equals P e to the RT. And we have the formula for compounded interest, and that's A equals P times 1 plus R divided by M raised to the MT. And that's going to be where P is the initial amount, R is the rate, A is the amount after T years, and M is the number of times that you compound per unit of T, and T is time. Let's do number 6. And number 6 says to find the time necessary for $1,000 to double if it's invested at a rate of 5.5%, compounded part A annually, part B monthly, C daily, and D continuously. So if we break this up into 4 different sections to go from A to D, we get that for part A we want annually. Well, annually is going to mean that my M is equal to 1 because we're going to use the formula for compounded interest. Well, we're given that $1,000 is the initial amount, that we're trying to get it to double, which means that A is going to equal 2,000, and that the rate we invested at is 5.5%, so R is going to equal 0.055. Plugging it into this formula to solve for T, because we want to find the time necessary, we would have 2,000 is equal to 1,000 times 1 plus 0.055 divided by 1 raised to the 1 times t. Well, dividing both sides by 2,000, we get 2 is equal to, and if we combine this, this becomes 1.055 raised to the t. Taking the natural log of both sides to solve for t, we get the natural log of 2 is equal to the natural log of 1.055 raised to the t. Using the power to product rule, making this t come out and multiply the front, we get the natural log of 2 is equal to t times the natural log of 1.055. Solving for t, we get that t is equal to the natural log of 2 over the natural log of 1.055. Using a calculator to figure out what t is approximately to 2 decimal places. To make sure we enter it in correctly, let's use alpha y equals for a numerator and denominator, and then write in the natural log of 2, and then in the denominator divided by the natural log of 1.055, and we end up with 12.95 years. So it's going to take 12.95 years for our money to double. Part B, monthly. How much is it going to take for monthly? Part B just means that my M is equal to 12. Everything else remains the same. A is still going to be 2,000. P is still going to be 1,000. And R is still going to be 0.055. We're still using the formula for compounded interest. So we end up with 2,000 is equal to 1,000 times 1 plus 0.055 divided by 12 raised to the 12t. Dividing both sides by 2, we get 2 is equal to, and here if I were to get a common denominator and multiply this by 12, this ends up being 12.055 divided by 12, and that's raised to the 12t. Taking the natural log of both sides, we'd have the natural log of 2 is equal to, and we're going to go ahead and skip to the part here where we're using the power to product rule. So this guy here is going to go and multiply the front. So 12t times the natural log of 12.055 divided by 12. Solving for t, and t is going to equal the natural log of 2 divided by 12 times that natural log of 12.055 over 12. So grabbing the calculator, again, alpha y equals for a numerator and denominator. We're going to have the natural log of 2 divided by 12 times the natural log of 12.055 divided by 12. And to 2 decimal places, that's 12.63 years. Part C is daily. The only thing that changes for Part C is M. M is now 365. A is still 2,000. P is still 1,000. And R is still 0.055. So we would say 2,000 is equal to 1,000 times 1 plus 0.055 divided by 365 raised to the 365t. Again, if I make this over 1 and multiply top and bottom here by 365, dividing by 1,000 first, we have 2 is equal to, and this just becomes 365.055 divided by 365 raised to the 365t. Taking the natural log of both sides and using that power to product rule, we'd have the natural log of 2, that goes and multiplies the front, is equal to 365t times the natural log of 365.055 divided by 365. Solving for t, t is going to equal the natural log of 2 divided by 365 times that natural log of 365.055 all over 365. Sticking it into a calculator and rounding to 2 decimal places, alpha y equals for a numerator and denominator, we'd have natural log of 2 in the numerator, and in the denominator 365 times the natural log of 365.055 divided by 365, and that's going to be 12.60 years. Part D, the last one, is asking us to do it continuously. Since it's asking us to do this continuously, we know that we're going to have to use A equals P e to the RT, the other formula for continuously compounded interest. So again, D is continuously. So we use A equals P e to the RT. Well, we still know that A is equal to 2,000. That P is equal to 1,000, and that R is equal to 0.055. So plugging it into this formula, we get 2,000 is equal to 1,000 e to the 0.055 t. Dividing both sides by 1,000, we get 2 is equal to e raised to the 0.055 t. Taking the natural log of both sides to solve this. Here the natural log and e are going to cancel because they're opposites. And we end up with the natural log of 2 is equal to 0.055t. Dividing both sides by 0.055 to solve for t. And t is going to equal whatever the natural log of 2 over 0.055 is. Plugging that into a calculator. Alpha y equals for a numerator and denominator, the natural log of 2 divided by 0.055, hit enter, and that's 12.60 years.